All right, ladies and gentlemen, we're talking about finding the greatest common monomial factor. Now, this goes back to the idea of finding the greatest common factor that we did with fractions, but we've also done with ways to be able to bring things out, like our general rule of like 36 is the same thing as 30 plus 6. And then we can use facts like this for distributive property, things like that. And it's going into the same idea as far as being able to use this down the road. What I mean is we've been solving monomials that are set equal to 0. But what happens if it's not a simple mono or polynomial? It's something more complicated. We're talking about now, how do we simplify that? So we know whether they're the same, whether they're different, because if they're the same, we only have to work it once. If they're different, we have to work it for every polynomial with an x in it. So here we have the example of 4x, did the wrong thing there. So 4x to the fourth plus 24x cubed. And what we're going to do is we're going to separate those in its own individual terms, or monomials, if you will. And so we're going to look at 4x to the fourth first, and that's written in blue on your screen. And then we're going to be looking at 24x cubed, and we're going to be comparing to see how we can simplify what that is. And what does it look like when we simplify? So notice off to the right for each of these monomials, I've already written out their factors. Now, this is not the greatest common factor. What we got to do next is find that greatest common factor. And what I'm going to do is I'm going to kind of group these up so they are similar. If you look now, I've grouped up those 2's, and here I'm grouping up the x's. What's happening when we find the greatest common factor and we are factoring out that greatest common factor is we are basically saying we take out these groups of 2's and just leave it as 2 times 2. In other words, I took out those 2's for each of them. And I'm going to leave in that 2 times 3. But I don't want to do that yet because now I also want to put in, next to this, these x's. This is our greatest common factor. It's not its simplest form, but this is our greatest common factor written as factors. So to simplify it, I just do the multiplication I see. 2 times 2 is 4. X times x times x is x cubed. And this right here is our greatest common factor. What it's done now is it has left this 2 and the 3 and this individual x out of our greatest common factor, which means we need to put them back in as our original. In other words, what's left of the 4x to the fourth is just 2 times 3. And then we had that plus sign. I want to say the pesky plus sign, but it's not really pesky. What was left of the 24x cubed is also going to be, or I'm sorry, wow, my brain, that is not right. That 2 times 3 was connected over here to that 24. What's connected it, so in other words, there's actually no numbers except there is an x right here that's left from the 4x to the fourth. So that x gets written where the 4x to the fourth was. That's what's left after we've factored it out. We had 2 times 3, which is what was left of the 24x cubed. And so 2 times 3 is 6, and I'm just going to write that here. 2 times 3 is our 6, and that's where that guy came from. So our greatest common factor is 4x cubed. And if I write this by factoring out that greatest common factor, what I'm saying is 4x cubed x times x plus 6 is the same thing as 4x to the fourth plus 24x cubed. So our answer really In factoring out the greatest common factor from 4x plus 4 plus 24x cubed is 4x cubed times x plus 6. The greatest common factor itself was the 4x cubed. But when it says factor out the greatest common factor, it means take that greatest common factor and write it as a product that equals the original.